So this is parabolic trough. As the name indicates, the solar collecting radiation surface is in the form of parabolic trough. So when the solar radiation is incident on this surface, then the entire solar radiation reflects and focus at that focal line of this parabolic trough. So if we placed the absorbing receiver at that focus line point, then we will get high temperature. So that we will see by using this. I placed this parabolic trough here, and you observe this, how the radiation is reflecting from this parabolic trough, and here is the focusing point. Now I am changing the position, then the focus point is also changing. What does that mean? The sun as rotating, the focus point is also rotating. So that's why we need the sun tracking system for this parabolic trough also. So here I am placing exactly towards the facing of the sun, then I am getting more intensity light point. Here is the more intensity. It is exactly, see, the 2.5 centimeters. It is focusing all the radiation at that point. So if we place it the absorber receiving pipe at this point, then we will get high temperature, which is used to heating the liquids. This is parabolic dish. As the name indicates, the solar radiation collecting surface area is in the form of parabolic dish. So when the sun radiation is incident, then the entire solar radiation is reflected and focusing at the focal point of this parabolic dish. So if we place the absorbing receiver at that focal point of this parabolic dish, then we will get high temperature. So that we will see by using the black paper. So now I am placing this parabolic dish like in this form. So you observe that this is the reflected radiation coming from the sun. So when the sun is radiation is incident on this parabolic dish, you observe that the reflected radiation focus point is here. Now it is here. As I am rotating this, the focusing pointing also is changing. So what does that mean? As the sun rotates, the focusing point of the reflecting radiation is also rotates. So that's why we need the sun tracking system. So here I am focusing all the radiations at some point. You cleanly observe this one. Yeah, this is the maximum focusing point, this one. As if we placed the absorber receiver here, then we will get the more temperature. Now coming to the solar tower or central tower receiving collector. Imagine this is a solar tower, and top of this tower there is an absorbing receiver. So this tower is located exactly at the center of the plant, and around this tower there will be thousands of mirrors placed, and these mirrors, as the radiation incident on this, all these mirrors reflects the radiation towards this absorbing receiver. So when the absorbing receiver is in contact with the fluid, that fluid will be heated to a high temperature. That we will see. So now I am placing this solar tower here, and this is a thermometer which is in contact. Just I am placing that these two are in contact with each other. Now let us see the initial temperature of this one. It is around 38 degrees centigrade. Okay, so now by using these reflectors, I am focusing the sun rays towards this absorbing receiver. So see how the radiation is focusing. You observe here, this one is the focusing point of this reflector. Now this I am changing the position and focusing towards the absorbing receiver. See, here it is exactly focusing on that absorbing receiver. And similarly, I am taking another reflector which is used to focus the solar radiation at the same absorbing receiver. Yes. So since both these two mirrors are focusing exactly on the absorbing receiver. Now let us observe how the temperature of this absorbing receiver increases. You cleanly observe this one. Now it is around 42 degrees centigrade crossing. It is initially at 38 degrees centigrade and now it is 43 degrees centigrade. See how rapidly it is increasing. Why? Because I am doing this experiment exactly in noon hours. That's why it is increasing rapidly. Now it is approaching 45 degrees. So by using only two reflectors, we are getting more temperature. So if we use heliostats, that means thousands of mirrors are focusing at the receiver, then how much of temperature we will get, you just imagine. Now coming to the last collector, it is Fresnel lens concentrating collector. So in that Fresnel lens concentrating collector, linear grooves are present at the one side of the lens and the other side is completely flat surface. So when the solar radiation coming from the sun incident on this flat surface, after refraction all the rays will be concentrated in this direction and focused at one point. So at that focus point, if we place the absorbing receiver, then we will get high temperature. So that we will see in this experiment. So for absorbing receiver pipe, I have taken as one copper wire and this is placed here like this, and instead of Fresnel lens I have taken an ordinary lens and I am focusing the sun radiation on this pipe. Assume that this is one copper pipe and I am placing one thermometer which is in contact with this pipe. So let us see the initial temperature of this copper pipe. It is around 35 degrees centigrade and it is slowly increasing. It is now reaching 36 degrees. It is slowly increasing because of we are doing this experiment morning 10:30 a.m. So in this way we are getting more temperature by using Fresnel lens concentrating collector. So dear students, we did all these experiments for demonstration purpose only. You can do these experiments at your home with innovative new ideas. Thank you.